To understand why Artemis II became such a massive moment in human history, we first need to understand where humanity had been before the mission launched. The last time humans traveled beyond low Earth orbit was December 1972, Apollo 17. Since then, every astronaut mission has remained relatively close to Earth. The International Space Station orbits only a few hundred miles above the planet. But Artemis II changes everything. Artemis II is the bridge between the old space age and the future. They did not land on the surface, but they performed a historic lunar flyby. And that flyby will give them views no human eyes have witnessed in decades. Massive impact basins stretching across the horizon, towering crater walls, jagged mountain ranges, dark volcanic plains, ancient scars from billions of years of cosmic violence. The moon is not a smooth gray sphere. It's a world frozen in time, a planetary archive. The first regions Artemis II observed were parts of the moon humanity already knew well. The near side. This is the face of the moon permanently turned toward Earth. Because the moon is tidally locked, we only ever see one hemisphere from our planet, but seeing it through a telescope and seeing it from orbit are completely different experiences. From Orion's windows, the lunar surface will appear massive. The astronauts will witness gigantic dark plains called Maria. These ancient lava seas formed billions of years ago after colossal asteroid impacts. One of the most famous is Mare Tranquillitatis, the Sea of Tranquility. This is where Apollo 11 landed in 1969. Neil Armstrong and Buzz Aldrin took humanity's first steps there. Artemis II astronauts passed over the same historic region. Imagine looking down at the exact place where humans first walked on another world. Those footprints are still there, untouched, preserved in vacuum. The American flag may still be standing. But the moon's near side contains far more than Apollo history. There are impact basins larger than some countries, towering crater rims rising thousands of feet high, and strange geological formations scientists are still studying. Take Tycho Crater. This massive impact scar stretches over 50 miles wide. Bright rays blast outward across the lunar surface like spider webs. From orbit, Tycho is breathtaking. Its walls plunge downward into darkness. Then there's Copernicus Crater, another gigantic impact feature. Its terraced walls reveal layers of lunar history. Scientists study these structures because impacts expose material hidden beneath the surface. In many ways, the moon is like a giant time capsule. Each crater is a window into ancient planetary history. But the near side is only the beginning, because the most mysterious part of the moon lies beyond, the far side. For thousands of years, humans never saw it. Ancient civilizations imagined monsters, hidden worlds, or secret realms beyond the moon's visible face. Even after telescopes were invented, the far side remained invisible. Then in 1959, the Soviet Luna 3 spacecraft finally photographed it, and scientists were stunned. The far side looked completely different. Instead of dark volcanic plains, it was heavily cratered, rugged, chaotic, almost alien. Artemis II astronauts witnessed this dramatic contrast firsthand. As Orion swings around the moon, Earth disappears behind the lunar horizon. For a brief time, the crew entered radio silence. No direct communication, no Earth in the sky, only the far side beneath them. This is one of the eeriest moments of the mission. Imagine floating above a world no human being has seen up close in decades. Below you lies terrain shaped by billions of years of impacts. Gigantic craters overlap one another. Mountain chains stretch across the surface. Ancient scars reveal the violence of the early solar system. One feature dominates them all: the South Pole Aitken Basin. This enormous impact structure is among the largest known craters in the solar system. It spans roughly 1,500 miles. Scientists believe the impact that created it may have punched deep into the moon's crust, possibly even exposing material from the lunar mantle. That makes this region scientifically priceless, and Artemis missions are heavily focused on the moon's south polar regions because they may contain frozen water. Water changes everything. Water can support astronauts. Water can produce oxygen. Water can even be converted into rocket fuel. If substantial ice deposits exist there, the moon could become a stepping stone to Mars. But the far side also has psychological power. Many Apollo astronauts described feeling isolated when Earth vanished from view. No blue planet overhead, no reminder of home, just endless black space, and the silent moon. Some astronauts called it beautiful, others called it haunting. Artemis II may evoke those same emotions all over again, because despite all our technology, the moon remains profoundly lonely. If there's one region scientists are obsessed with right now, it's the lunar South Pole. This area may become humanity's first permanent foothold beyond Earth, and Artemis II played a crucial role in studying it. The moon's poles are unlike most places in the solar system. Because the moon has almost no axial tilt, sunlight strikes the poles at extremely low angles. That creates permanently shadowed craters, places where sunlight has not reached for potentially billions of years. Inside those shadows, temperatures plunge to unimaginable extremes, colder than Pluto, colder than many regions of deep space, and scientists believe water ice may be trapped there. This discovery transformed lunar exploration. For decades, people assumed the moon was completely dry. Now we know that may not be true. Scientists continue debating how much ice exists and how accessible it may be. But if the ice is abundant, it changes humanity's future in space. A lunar base near the South Pole could harvest water for survival. It could produce breathable oxygen. It could manufacture fuel for deep space missions. The moon could become a fueling station for Mars exploration. That's why the South Pole matters so much. Now we need to address something that always captures public imagination: the strange things people claim to see on the moon. Over the decades, observers have reported mysterious flashes, unusual lights, odd surface features, even temporary color changes. These events are known as transient lunar phenomena. And while many have scientific explanations, some remain uncertain. For centuries, astronomers documented glowing regions and brief flashes on the lunar surface. Modern scientists believe some may result from meteor impacts. Others could involve electrostatic effects or gas releases from beneath the surface. The moon is not completely inactive. Tiny moonquakes occur. Micrometeorites constantly strike the surface. Dust can behave strangely in low gravity. During Artemis II, astronauts and instruments observed subtle lunar phenomena in unprecedented detail. Imagine seeing sunlight reflect across jagged terrain, or witnessing meteoroid impacts creating brief flashes. These moments remind us the moon is not dead. It is dynamic in ways we're still learning to understand. Then there are the optical illusions. The moon's lighting conditions create bizarre visual effects. Long shadows distort scale. Craters appear deeper or shallower depending on sun angle. Mountain peaks can look artificial. Some formations resemble towers, domes, or geometric structures. This has fueled conspiracy theories for decades. But scientists generally attribute these appearances to natural geology and extreme lighting. Still, when humans return and witness these landscapes with their own eyes, public fascination will explode. Social media will analyze every image. People will search for mysteries everywhere. And honestly, the moon already looks mysterious enough, because it is a world frozen in silence, a landscape untouched by weather, an alien desert hanging in space. Sometimes reality is stranger than fiction. One of the most important parts of Artemis II won't be scientific at all. It will be human. What does it feel like to leave Earth? To travel into deep space? To stare at the moon through a spacecraft window? Apollo astronauts described overwhelming emotions. Some experienced awe. Others felt isolation. Some became deeply reflective. Astronaut Edgar Mitchell famously spoke about a profound shift in consciousness after viewing Earth from space. This experience is sometimes called the overview effect. When astronauts see Earth from far away, national borders disappear. Artemis II astronauts experienced that same realization. And unlike Apollo crews, they'll share the journey in the age of high-definition cameras and global live streams. Millions of people could witness parts of the mission almost in real time. Children watching today may become the first humans to live on the moon. That emotional connection matters, because Artemis is not just about science, it's about inspiration, about proving humanity still explores, still pushes outward, still dreams. Think about the psychological impact of seeing the far side of the moon with your own eyes, or watching Earth rise above the lunar horizon. That image changed history during Apollo. The famous Earthrise photograph helped reshape environmental awareness on Earth. For the first time, humanity saw our planet as one shared home. Artemis II created a new generation of iconic images. Images that inspire future explorers, future engineers, future dreamers. Because exploration has always done something powerful. It expands the human imagination. One of the biggest questions surrounding Artemis is simple. Could humans actually live on the moon long term? The answer is complicated. The lunar environment is brutal. There's no breathable atmosphere. Temperatures swing violently. Radiation levels are dangerous. Micrometeorites constantly bombard the surface. And lunar dust is incredibly sharp and abrasive. Apollo astronauts discovered that moon dust clung to everything. It irritated eyes and lungs. It damaged equipment. Future lunar habitats must overcome all these challenges. But despite the dangers, the moon offers enormous advantages. Its gravity is weaker than Earth's, making launches easier. Water ice could support life. Solar energy is abundant in certain regions, and the moon's proximity to Earth makes resupply missions possible. Scientists are already designing concepts for lunar bases, inflatable habitats, underground shelters, 3D printed structures made from lunar soil. Some researchers even propose using lava tubes as natural radiation shelters. Artemis II became part of that long-term vision. The astronauts won't build bases themselves, but their mission helps move humanity toward that future. And imagine how surreal that future could become. Humans living beneath the lunar surface, driving across ancient craters, watching Earth rise in the black sky, mining resources, launching spacecraft toward Mars. The moon may become humanity's first true off-world civilization, and Artemis II is one of the first major steps. When Artemis II returned safely to Earth, something changed, not just for NASA, not just for space exploration, but for humanity itself. For the first time in more than 50 years, human beings had traveled back into deep space. They had flown around the moon, seen its ancient scars up close, witnessed the far side with their own eyes, and reminded the entire world that exploration was not over. It was beginning again. The mission proved that humanity could once again leave Earth orbit and survive the journey into deep space. Every system tested during Artemis II became a foundation for the missions that followed. The Orion spacecraft, deep space navigation, crew survival systems, communication networks, radiation protection. All of it mattered, because Artemis II was never just about one mission. It was about reopening a door that had been closed for generations. And beyond the science, beyond the engineering, Artemis II reignited something even more powerful: curiosity. Millions of people watched the mission unfold. Children stared at the moon differently. Students began dreaming about becoming astronauts. Engineers imagined future lunar cities. Scientists prepared for discoveries still waiting beneath the moon's frozen surface. For a brief moment, the entire world looked upward together. And maybe that was the mission's greatest achievement. Because when the astronauts looked back at Earth from lunar distance, they didn't see countries, they didn't see borders, they saw one world. A small blue sphere floating alone in darkness. Beautiful, fragile, and incredibly rare. That perspective changed Apollo astronauts forever, and Artemis II carried that same message into a new generation. The moon itself also looked different after the mission. No longer a distant object in the night sky. Now it felt real again, a place, a destination. A world humanity could reach. The craters Artemis II photographed, the frozen shadows near the poles, the endless deserts of gray dust, the towering mountains and ancient impact basins. All of it reminded us that the moon is not just a symbol in the sky. It is another world waiting to be explored. And Artemis II proved that humanity still possesses the courage to explore it. For thousands of years, humans looked at the moon and imagined what was waiting there. Ancient civilizations worshipped it. Poets wrote about it. Scientists studied it. Dreamers imagined walking across its surface. Then humanity finally reached it during Apollo, and after decades of silence, Artemis II reminded the world that the story was not finished. The moon still holds mysteries, hidden ice, ancient geological secrets, untouched regions no human has ever explored, and perhaps discoveries we haven't even imagined yet. But one thing became clear after Artemis II. Humanity was no longer standing still. We were moving outward again, back toward the moon, and eventually beyond it. So the next time you look up at the moon, remember this: human beings went back. They saw the ancient far side once again. They crossed the darkness of deep space, and they opened the path for the future. The story of lunar exploration didn't end with Apollo. Artemis II proved it had only just begun.